Starting right off, we're going to have Zoe, Andrew, Aiqun, and Elaine for our first panel, Riding the AI Wave Together, Learning, Leading In, and Leading.
Hi everyone, thank you for coming to our panel. We're going to start off with some introductions for ourselves. Okay, hi everyone, my name is Elaine. I just finished my first year at Cornell. I'm studying electrical and computer engineering, and I'm minoring in computer science. I'm from the Bay Area, California, like the Cupertino area. At school, in my free time, I'm part of the Society of Women Engineers. We basically just go to local elementary schools and teach the students there about STEM and all things science related. I dabble a little bit in AI. I've done a little bit of research with it. At school, I'm also on an autonomous car team. And in a couple weeks, I'm going to be starting another summer internship that is also related to AI. But I am no means an expert with AI. I'm just learning it like most of you. I'm just here to share my experiences with learning it in school and on my own. Yeah.
Hi everyone, my name's Andrew. I am a rising junior now at CMU, and I'm studying computer science. I recently transferred. I was studying EC before. And I'm also from the Bay Area, from Palo Alto. And in my free time, really love playing chess. Hope you guys are also chess players. If you're not, you should become a chess player. So at CMU, I'm part of CMU's chess club. We do a lot of events and stuff, play a lot of chess, have a lot of fun, go out for tournaments and do a lot of that. And also, I've done AI-related research in high school, and I've also done AI-related internships. So last summer, I was at Microsoft in Beijing, and this summer, I'm currently at TikTok, and I've just done, well, I just finished my week 2, so, you know.
Okay, now I'm going to introduce some of our co-panelists. So on the left is my dad, who's going to introduce himself.
Good afternoon, everyone. Pleasure to be here. I feel actually a lot younger just to be here. So my name is Aiqun. I don't have an English name. I went to Tsinghua in 1994 and spent 6 years there, double E for bachelor and then a master in the Institute of Microelectronics. So my wife and I, we came to United States in 2000. I finished my Ph.D. from Purdue and graduated in 2004, and then joined the same company I have been working for now 21 years. The company is called Synopsys. I'm an SVP there, leading a large engineering team. The product line I'm responsible for is for chip design. Many of our customers that you may have heard, NVIDIA, AMD, Apple, and so on. My wife and I have 2 wonderful daughters. Elaine is the younger one here. The older one, Jacqueline. She's busy preparing for her MCAT test, so she's not here. I'm looking forward to share with everybody some of our own experience on AI. Looking forward to a very productive panel. Thank you.
Yeah, great. Thank you for your introduction. Now I'd like to introduce our final and last co-panelist, my mom.
Yeah, this is Zoe, Chinese name Liu Yuxin. I'm Andrew's mom. I was actually in Tsinghua for 10 years, from 1990 to 2000. So actually, I was 4 years grades ahead of Aiqun, but we came to the United States and attended the same school at Purdue. I got my second PhD there. So it's different from Aiqun. I actually got several jobs. So I was once at Nokia, then moved down to the Bay Area. I was one at Apple, there's a startup, followed by Google. I was first working on Google Glass, and followed by working mainly some code extenders and support backend of YouTube. But my career has all been staying in video compression. So that's why 2018, after new standard finalized at Google, I got a startup. So right now I'm the co-founder and CEO of Freenuller. And so I also feel honored to be with the younger generation and facing all of you now. And there's a lot that we can discuss even in the panel and afterwards.
Okay, so now we're going to give a little deeper introduction as to our background with AI. Next slide, please.
All right, let me start first. When we talk about AI, it's not just ChatGPT or autonomous driving. Actually, AI has a full stack, and that's what that top left diagram was trying to show there. I know it's a bit hard to see every company's name there, and rest assured, my company's name is not there. Zoe's company's name should be there, but. So if you look at the sort of the whole AI stack, at the bottom is really the hardware, and this is where the GPUs, as well as the connectivity, to bring those GPUs together, for companies like NVIDIA or Broadcom. If you are in the EE area, maybe you are more familiar, or in the semiconductor area. But that's really where sort of the compute power is enabling today's AI, because AI has been there since maybe 50s and 90s, 50s and 60s, and now I think this is the first time really that you see AI is making such a big leap forward, and part of that is because of the compute, and then of course you need the data, you need the model or the algorithm part, right? If you are following the news, a week ago, Donald Trump visited Middle East, and he pretty much took all the CEOs of almost the entire AI stack with him to visit Saudi Arabia, who made 600 billion commitment on the investment, and a good part of that is AI. And we had CEOs from NVIDIA, from AMD, from OpenAI, from Amazon, and that's where that you see that sort of pretty much the entire stack is there for AI. Now, what my company is doing, and that's on the top right there, Synopsys is in the EDA industry. It's called Electronic Design Automation, and we're the ones in essentially providing the software for semiconductor companies. Like I mentioned, NVIDIA is one of the most important customers for us these days. But that's really today, when you design a GPU, with billions of devices on it, obviously that there's no way you can do it all by human. You need the software there. And at the same time that we are actually trying to utilize AI to make that software and to improve the productivity, to improve the performance, to reduce the power, and all that good stuff. That's what we're trying to do there. So in a way that you can consider that we're the enabler for the semiconductor companies, and the semiconductor companies are the ones really enabling the AI from the compute front. The bottom ones that are the pictures are about some of the products that my team have been responsible for. That we rolled out different generations of AI products, of AI solutions in the design automation space. Starting from reinforcement learning for optimization and design. More than 6-7 years ago now, to generative AI when GPT came out, and now we're on to just like autonomous driving. There's the L1 or L0 to L5 in chip design. This is what we're looking at to also get to using agentic to get to autonomous chip design. That's what we're doing in that space.
Next slide, please. Yeah, so I mentioned earlier that I have a little bit of experience with AI through a research project that I did centered around the utilization of deep learning models for processing physiological data from electrocardiogram, or better known as ECG signals, with the focus on QRS complex detection. So this phase is pivotal in ECG signal analysis because it reveals crucial heartbeat information, which is also a precursor to heart disease classification. So I worked extensively with the MIT BIH arrhythmia database, and basically that's just like millions of 1D ECG signals, and then in PyTorch we converted that into 2D output energy heat maps, and through that, we developed a LSTM network to basically find the precise localization of the art peaks, as you can see from that image. And also at school, as I mentioned, I'm on this team called Cornell Electric Vehicles, where we're trying to be the first ever college team to develop a level 2 autonomous electric car from scratch. Personally, I am on the electrical sub-team, but we work closely with the autonomy sub-team who's working on some pretty cool things to get our car to be self-driving soon. And so one of the things is visual segmentation, which is basically taking the images and videos that the camera sees and basically just dividing that or segmenting that into different objects. Like from that image, being able to tell that the tree is separate from the background and the ground. And then they're also working on using the YOLO real-time object detection algorithm, which can basically classify the objects that it sees. So basically putting a box around that tree and saying this is a tree versus a car. And they're also working on neural depth, which is using a Z camera with 2 lenses to sort of simulate depth, kind of like human eyes, and using a depth estimation neural network to sort of, based on visual cues, estimate the depth of the objects that the camera sees. Next slide, please.
Yeah, this is about us. As I mentioned, I have been doing the startup. We're mainly focused on video compression. That's the core. And so basically, everybody has experience when you share a video file, especially when the network is not good. It's actually the file pretty big. What we are trying to do is make the file smaller, but still maintain similar, if not better, visual experiences. Also follow the standard format so that whenever you open it, it should be opened the same way as all the others. And the fundamental thing is you just imagine from where you sit. If you take a video of all of us, you see actually it's a video of the panel, but inside the video, the different content. So background, this is a screen content because this is all computer-generated content. And computer-generated, for example, if you get a PPT presentation, if the background is white, everywhere is white. But if this is a white wall, inside the video, because of the lighting, because of the noise, it's not everywhere the same white. So these are 2 different content. We actually realize every video is different. If you differentiate them, you may get even better compression, but even better visual experiences. And also, I think Elaine just mentioned, you can also identify some object. So look at our video, what's important? Besides this background, the faces of our 4 is definitely important. So if you are able to identify those are the faces, is also we call it perceptually significant area because human eyes are the ultimate observer. They pay attention to this object. So what you need to do is pay a little bit more bits to allocate the faces of us. Then you will get a nice faces, but all the others 4 doesn't matter. So this is what we are trying to do because you're trying to understand, categorize the different videos and process them differently. So that's why it's intelligent. So this is the core of our technology, deploying AI for video compression to make it better and to make it smaller. And then fundamentally, we also did some other AI project because for video, you want to say, hey, for every given video, it is in good quality now. So we have the video quality analyzer. We also have some things. If I identify, for example, we do a live stream of sports. If I identify maybe on the grass, that's not so important. You can actually add virtual ads. And that ads can also actually change along different regions and different content. So that's about us. We're leveraging AI to process video, providing the fundamentally best possible experiences.
Okay, next slide. All right, I'll go last, a little bit introduction about me. So I did research with Purdue's Viper Lab. It's their video and image processing laboratory, and that was a couple years ago, and I co-authored a couple papers. And this is about like the paper that I first authored during my research. So my research was about food images and using self-supervised learning algorithms. So in machine learning, there are a couple of types of different algorithms. You have the most common ones. The most ones are like come to mind is like supervised learning, where a model is trained on a couple images. The images have a few labels, and the model realizes how to classify those images. But in the real world, right, there's a lot of images that are just unlabeled. Like no one's had the time to go through each of like the millions of images on Instagram and go through and label exactly what's in each of the images. So self-supervised learning is a type of like classification algorithm where the model will go through all of these unlabeled data and learn some features, and then use those features and then retrain the model on a small subset of labeled data sets, so it can actually perform classification. And my research was applying this to food images. So food images have a few slight differences between, like, you have normal like images about like the main large data set is the ImageNet data set. It's very, very famous, has a lot of different categories. But food images are slightly different because in food images, you have a few similarities between different types of food, but also within each type of food, there is also a lot of differences. Like the example I gave in my presentation when I presented this paper was about like chocolate cake versus carrot cake versus cheesecake, a lot of different types of cake. They all do look quite different, but sometimes the cakes look the same. So that was a bit about my research. I looked at different self-supervised learning models and evaluated them on food images. And then later on, last summer, I was at Microsoft, and I was helping modifying the ads ranking model, which is what Microsoft, when everyone hates it, but it happens whenever you search something on Google or Microsoft, you're gonna get a couple ads. It's how they make money, but they want these ads to be good, and you also want these ads to be good. If you just get some random ads, you're gonna be annoyed. But if you get some ads that somewhat relate to your search, you can be like, okay, sure, they exist. So it's better for the company and also the user to have good ads. So we were working on the ads ranking. Okay, so yeah, that's all about us. So now we're going to get into the actual Q&A, which I'm sure you guys are mostly here for, not really about us yapping about ourselves. So let's get into the first round. So first we're going to ask a couple questions for the parents, and then they'll come back and ask us a couple questions. And I'll start it off. So with the rise of AI and large language models being absolutely everywhere, how have they disrupted or interrupted or changed how your work, your work process?
All right, I can start. Absolutely that AI is everywhere. It's pervasive, and I think in every industry that every CEO, so included, everyone is trying to figure out how they can leverage AI and at the same time not to be disrupted by it, right? So from my own experience at Synopsys, that not only we're trying to come up with our own AI products or AI augmented products, this is what I'm referring to as AI for chip design, but also internally within the company, we're trying to improve our own productivity, own efficiency using AI. So, for example, I think Microsoft or Google have already announced that 30% of their code basically are written by AI these days. We're not there yet. I would say probably we're maybe 10-ish percent-wise. That's what we're seeing at this moment, because in our industry, there are a lot of sort of very classic EDA problems. These are MP complete or MP hard problems, which today's AI is not really ready to replace. And we're not too worried about that AI will get to that level anytime soon. But in the future, it could be. That's why I mentioned that we're also worried about whether that we're going to be disrupted by some startup later on, and we're doing our own homework or research on, okay, really, if I completely using or relying on AI, can I completely get rid of all the classic algorithms, which is really sort of the core asset that we have at the company. But just from the productivity front, I would say that we definitely see a boost already. And personally for me, that I use Microsoft Copilot or Copilot, to summarize the emails or stuff like that. That already improve the efficiency of myself, I would say.
I think follow the spirit is when AI, actually back to 2018, when we're founded, we were trying to do a new standard solution. That standard was called AV1. So we actually made our business plan, where when they pitched to these investors, we told investors, oh, we are doing AI for AV1, which actually short as A squared. But we will now actually realize later on AI was this hard. As me, we definitely, because Aiqun said they're a big company, they have to be being alert. Those startups may come up with disruptive technology solutions. The same thing with us. We are doing things we don't want to suddenly, one day we feel like our technology is already obsolete. There's already like some others completely resolve the issues that we are trying to resolve. But you have to bear in mind, fundamentally, I encourage our teams, whenever there's a challenge, that means there's opportunity down there. So originally, when we were founded, because we were mainly focused on compression, so we actually core algorithm team, we have one part working on video compression, the other part, because we're doing AI, we're trying actually that team to support the core codec team. But right now, 7 years later, the AI team by itself already rolled out independent product besides our compression. Like I just mentioned, we do some AI voice tracking, virtual ads insertion. On top of it, NVIDIA is actually used to become our largest competitor potentially because they roll out a GPU. If you are aware, every GPU comes with a hardware encoder, short as NVINC. And then, so we start to notice every customer came to us say, hey Zoe, you provide your encoder. How do you compare against the GPU's NVINC? The horrible or kind of like scary thing is when they actually purchase GPU, it's come up with NVINC for free. Then when we sell our encoder, we have to actually collect some revenue. Then we have to be able to allow better than NVINC. Otherwise, why people want to buy our solution? So then our strategy is why not we are able to leverage the existing NVINC, and also because it's always sitting with the GPU, and GPU has a lot of resources because they support very complicated neural network models. So what we are trying to do is for the past few years, maybe especially for the past 2 years, we actually deploy our neural network, especially on the top of the GPU. So because the GPU allows us to adapt and deploy more complicated neural network, so that we leverage that resources, develop a more complicated algorithm, especially identify the video quality. We can actually, for every single video, give it a very accurate score and also sub-scores to decide whether this video has noise, blocking artifacts, whether the color is overexposure, or whether because it also has some content not so good. And on top of it, we actually enhance the video. Just now Lauren mentioned, if you identify the noise, we remove the noise. If we identify the faces, we actually protect that area called region of interest. Then deploying all of this before we actually pour underneath NVINC, we are able to boost the smaller size by at least 30%, but even better quality compared to NVINC. So this is actually roll out our new product line. We are doing GPU-enabled AI encoders. So giving example, meaning that it's always, we face a lot of challenges, but you have to take it. And I think the young folks mentioned that you have to be actually believe in yourself and feel confident and face the challenges.
That's interesting, thank you. So we talked a little bit about how AI has disrupted your work, but I want to talk a little bit about how your companies are managing the use of AI. I know that a lot of young people are concerned about AI's environmental impact. How do your companies address the growing energy demands of AI while still maintaining product quality?
I just follow you.
Actually, very good question. Obviously that AI is propelling the society forward, but at the same time there are costs, right? There are many aspects to that challenge, but just the power or the energy consumption is definitely a very key challenge or problem there. I would say that we all share that responsibility, and this is where that actually I'm looking forward to the younger generation to come up with a breakthrough. I don't think that sort of the current approach. If you look at a lot of the big companies, in a way, are in a race to have more compute, more data, bigger model, which consumes more power for sure. And definitely that is not a scalable approach. So from that layer, I'm sure that when DeepSeek came out with a lot less requirement on compute to come up with a very capable model, I think sort of opened everyone's eyes, and definitely there are more innovation there. And then in the semiconductor, in the chip company, that's where that a lot of attention are given to energy efficient computing, and this is where that we're part of that effort as well. We work with our partners and our customers to see that how we can help reduce the power of every single chip, every GPU, and so on. This is the pitch that I give to my team, to my R&Ds. Hey, think about one project that you do that is improving the algorithm that will translate to, let's just say 2% of the power of a chip. But think about that chip is being used in every data center, in every laptop, in every PC. How much energy you are helping to save for the entire world, and think about that value of the project that you are doing, right? And literally that's where that algorithm level innovations keep really raising the bar and help contributing to that cause. But I think that's where that I feel it's still more incremental. I feel that a lot more breakthroughs are needed, and like I said, I am looking forward to maybe everyone here that you can help with that cause.
I think Aiqun is doing the chip design, and then hardware, actually chips always trying to get lower power. That's the advantages. Talking about our solution, because we still have a very important product line offering software, and software has to work on the CPUs, and then it complicated algorithm always costs a lot of powers. But for example, if you have a phone, either Android or iPhone, not sure how many, I know many of you use Discord, but also a lot more people, at least worldwide, use WhatsApp. And then they use WhatsApp to communicate. For example, if you go to India, because right now we have a team down there, almost every single Indian people, they actually has WhatsApp, and they use still making video calls. And then their device is actually very, many of them is at the lower end. And indeed, WhatsApp come from Meta. Meta actually deploy WhatsApp underneath using software encoder. So meaning that inside of WhatsApp, while you do a video call, it was powered by software solutions. So how could that even work on a very low-end mobiles? Because mobile really care about compute. So of course, it's used a lot less power compared to, I think Elaine mentioned that there's a lot of AI running on the servers. They actually consume a lot of power, but even on the mobile, they are very sensitive because you care about battery life. You care about whether it's actually become heated. It always actually will affect the user experiences. So it was actually optimized by the algorithm. So for example, when you do a video call, important thing is the face. And as long as you actually protect the face, you actually can do a good job. So that you can leverage, for example, if the chip down the road, always chip design, because it comes with a low power. Hardware is always using lower power than software. If you can just design with a face detector, then you can expose that API to tell the encoder, this part is face, please allocate more bits, and all the other you may rapidly ignore, then that would be ideal. So down the road, I would say that we keep the lower power the thing has to always in mind. Not only on the server, there's a lot of mobile devices, a lot of edges, and then, for example, I think a lot of people like hiking, and also there's a lot of some other careers that you carry a portable devices, and then the power always be issue. You can't always get the power from somewhere. Even you have a portable battery. It's always. So I just want to alert that getting something with a low power is not just making things great, but also make things work. This is very important. There's always a way, potentially, we can make this lower power.
Okay, great, thank you. I guess we can move on to the next round where we'll switch things around and we will be asked questions by the parents. So this will be a little bit interesting. So next slide, please. Oh, yes, this slide.
Nice.
So,
all right, parents can grow you. Okay, maybe the first question is more interesting for the younger generation who are still new to AI or who are younger than you guys. What when it's classes or trainings at school or by yourself you've been taking, you feel that has been very useful in preparing you for AI?
Okay, I guess I'll answer this one first. So, like I said, I'm a rising junior, so I completed 2 years of CMU schooling. And in those 2 years, I just recently took my first intro to ML course. Before that, you're taking a bunch of prerequisite courses like calculus and probability. And I think, after taking all of these classes, I realized that if you want to really understand how machine learning works, if you want to, from the fundamentals, understand how does a model begin to learn instead of just okay, you can understand the high levels. Understanding the high level concepts of machine learning is not too hard. You can learn it online. You can learn it by playing around with ML models. You can learn how to train your own model. I mean, I remember all the way back when I was a junior, but in high school, I started playing around with a few open source AI stuff. I coded up this handwritten digits in a classification model. It took 10 lines of Python code. Anyone can learn it. Even if you guys are in high school, middle school, you can just code it up and learn the basics. But if you want to understand, how to go about and learn the actual mathematics behind ML and learn how to build the next generation of AI, it seems to me it's it takes a long time and it's a long process to take a lot of classes and understand the fundamentals. But there's also the sense that you don't actually have to go through that long, arduous process of going and then taking all these classes and getting a Ph.D. in ML. A lot of jobs want you to have a Ph.D. in ML these days. You can understand ML, use machine learning to a point where as you're learning these classes, as you're learning these skills, they don't have to be directly for creating machine learning models, or they don't directly have to be for the purpose of developing an ML model. So for example, if you're taking a calculus class, right? Part of the reason you're taking the calculus class is to learn calculus, of course, but another one is just to build problem-solving skills. And just building these skills, I think, is the main point of learning. It's to build skills that are transferable later on when, AI is constantly evolving. You're going to learn something today, that this new, all these new models are coming out about large language models, and then who knows, maybe 1 year from now, 5 years from now, 10 years from now, or maybe tomorrow, someone's going to come up with a new type of model that just completely blows this out of the water, and everything you learned is obsolete, sort of. It's just, you need to, it's not really about learning the real mathematics. It's not really about learning how ML models works. It's just learning about how to learn and how to adapt in schools, to how to adapt to the constant evolution of machine learning. And I think that's what I've learned throughout these 2 years. Is how am I going to learn to adapt to more models coming out, and how I'm going to continually learn the process like learning how AI works. And I think that's like the main point of school.
Yeah, as I said earlier, I just finished my first year at Cornell, and as for most schools, when you first start in engineering, they force you to take all of these general classes like chemistry and physics and differential equations, and so I haven't really gone into the AI or the ML classes, but looking into the future, I mentioned earlier that I'm pursuing a CS minor. At Cornell, they offer like an AI minor that I'm also considering, and what this minor basically offers is just a bunch of classes on learning the mathematics behind AI, but also the politics, the ethics, and then relating it to health or like law or anything. But what I do know about these classes is that they're constantly changing. The Intro to ML class that was taught this year is probably not going to be the same one that I take in a couple years, and they preface it on the website that these classes are constantly changing and new classes are constantly being added. And so to add on to Andrew's point about how these universities are also adapting to this rise of AI, and so these classes are like I said, constantly changing, and so being able to sort of take what you're learning in your classes and not just memorize them, but understand what they mean, and sort of like learning how to think about AI, I guess, and not just learning the AI itself is important. And so I'm also part of the autonomous driving team at my school, as I mentioned, and a lot of the AI stuff that I've learned has come from there. So I think that while it is important to take these classes and learn what your professors have to say, all of these things, come from textbooks and are things that AI could probably tell you and read the textbook in a couple minutes. And so I think it's also important to do hands-on work, and sort of being able to apply what you learn in your classes will also be more helpful for you in the future.
Yeah, I think we have like time for like a couple more questions.
Okay, yeah. So thank you. But I still want to ask because when I was at school, and then your later professors indeed were encouraging us to use as many tools as we could. But right now, we're still wondering. There's so many like ChatGPT because I use that on a daily basis for write down my emails. Just wonder in school what are allowed. Like what kind of tools or how they actually make the use. So what AI can be used or cannot be used.
Yeah,
How do you think about that?
Yeah, I guess I'll start again. So at CMU, there is a very, very strict academic integrity policy where we have this term AIV that we throw around. I don't know if other schools also have that term, but at CMU it's like a very scary thing. They're very, very strict. You get 2 of them and you're immediately expelled. Most classes ban the use of AI and large language models. And it's understandable. They want you to learn the material. They don't want you to rely on ChatGPT doing all of your homeworks. But I've also heard of some higher level classes just allowing the full use of AI. So there's 2 types of classes. You have the intro level classes where AI can actually do all the homeworks. This is very obvious to me. So I'm also a TA for one of my classes at CMU, and it's an intro CS class. It's every now and then, you get to come along with an answer, and it looks AI generated, probably is. And you can tell that, AI can do this class. They can solve these homeworks because they're very standard homeworks. They ask you how to write these for loops that solve some basic problems, or what is going on in this linked list, or something like that. But then later on, you're going to reach these classes where AI has not reached a point to where it can solve the problems that you're given. The classes are going to become hard enough, the problems are going to become hard enough. The ideas, the concepts, AI is not going to be good enough to do at this moment. And I think this is pretty important for some classes to consider that the use of AI in classes can and maybe should be encouraged in those senses. Because when I'm currently working at TikTok and at Microsoft, no one really cares how much AI you use. You can use as much AI as you want. You can ChatGPT all your code, as long as your code works and doesn't have bugs and it produces the right answer. Because in industry, it really doesn't matter if you're ChatGPTing everything, as long as everything is working. And I think in schools, you also should learn how to use this tool instead of, in school you're saying you can't ever use ChatGPT. It is good to learn how to use ChatGPT. You just don't want to rely on ChatGPT. You don't want to ChatGPT through all of your classes, because then you're going to graduate and you're going to be like, oh, I don't actually know how to do anything. ChatGPT just knows how to do everything, and then you don't have these skills that like will transfer later on when you learn something new. You won't have to like you won't be able to learn it if ChatGPT can't do it. And I think like learning how to use ChatGPT as a tool to help you learn is also important. Like not just ChatGPT, like all the AI in general. Like so, for example, when calculators were invented, like you don't have to learn how to do complex multiplication. Like I've never multiplied a 2-digit number by another 2-digit number ever by hand since like 5th grade. It's like very, very kind of the same thing, same idea. Yeah, okay, we can go to the next slide, very last slide. Very last slide.
Yeah, so just to close off, we had tried to pose the last question and then use AI to make this cute little photo of the 4 of us. But as you can see, this is an example of the limitations of AI by the clear typos that are up there. And so this was just an example that AI is still growing and there's still a lot to do, especially for Gen 2. And yeah, I don't think we have any time left. So thank you everybody for listening to our panel and thank you for coming.